Evening, Emerald Hill skies. Welcome to another night of observing together Team Astronomy. We're glad you're here. We are located on the outskirts of Louisville, Kentucky. Our observatory is about 200 feet outside the window here of my office. And I just thought I'd share, when we built this observatory, what we started with was the pier. And we went down below the frost line with pouring this concrete column. You can see the concrete pad there and the walkway that we built up to it. We named the observatory Emerald Hill Skies. And it's a Pier-Tech Tele-station 2 observatory with a roll-off roof. And you can see the telescope peeking up above the roof line there. It's actually an adjustable height pier also from Pier-Tech. So we can actually raise it so that the mount is roughly level with the top of the roof. And we've got a yellow arrow in this shot that's pointing at that adjustable height pier. It's really a pretty cool system. The thing that we'll be observing through tonight instead of an eyepiece is a camera, ZWO ASI 2600 MC Pro Color Astrocam. That camera is located where you would normally have the eyepiece, or actually with a Newtonian reflector, you'd have a little diagonal mirror there that would bounce the light up to the side of the tube, and you'd look through an eyepiece there. We are eliminating that eyepiece and eliminating that little diagonal mirror in favor of this camera. It's actually sitting out in front of the telescope on a glass corrector plate. On top of the telescope, there's a little platform, and on that platform is riding another camera, and that's a ZWO ASI 178 monochrome camera. We use that for the sky views that we'll show you in just a second. The mount is particularly fun because it's extremely, by God's grace, extremely accurate. It's an iOptron CEM70 mount, and what the mount does is it points the scope in the directions that you want the scope to go. At the base of the scope, there's a box full of other gear that has to do with power supplies and the like, and all of that gear is listed in the description, what some people call the show notes, the description underneath this video. The heart of the system out there at the base of the scope is actually a little miniature PC. That mini PC is actually a fairly smart, fairly fast i7 PC that doesn't even have any kind of screen out there, no keyboard. It just calls in the data, and then what we do here is we connect to it through what you might think of as remote desktop software. We're using a different software called SplashTop, and that software takes care of connecting us to that computer so we can see what it is seeing. So why don't we get to that right now? Let's see if we can see what it is seeing first by taking us to the sky cam. And I think it's particularly helpful to look at the sky cam because we can see how bright everything is out there. The city of Louisville and the dome that's up there. Let's go look at Stellarium, which is our planetarium software, you might call it. And we'll sync it to where the telescope is looking and see that we're looking in the direction of south and then a little bit to the east. So you'd have to call it south-southeast right there. And by the way, that's where my truck is parked tonight. That's not a live view of my truck. It's actually a photorealistic horizon that we put just to kind of give us an idea of where things are. And then we use this red line as the actual horizon. So we're kind of low on the horizon with this object. It's just up roughly 16 degrees above the horizon. But it's pretty good horizon in that direction, isn't it? We don't have a very high tree line in that direction. And that's hopefully going to enable us to see what's there in just a moment. I just wanted to point out that right around here, let's find it. Where is the moon? We should be able to see the moon here somewhere because it's... Why am I not seeing the moon? It should be fairly bright. Does anybody else see it? Why am I not seeing the moon? Anyway, it should be roughly, I guess they just have it in stellarium. They just have it as a little disk. Tell you what, let's do. Let's go. Let's just search in the old-fashioned way here. Ah, there it is. So there's the moon, and it's about 77% illuminated tonight. So you can see it is bright. And our software tells us the distance as far as the night sky goes. You know, we kind of pretend that the night sky is a bowl, and then we mark off that bowl in 180 degrees across the whole night sky. And that lets us see how far we are from one object to the next, you know, for the moon. Our software tells us that we are about, let's see, where is that column? 31 degrees away on the night sky. So if you were to mark off the bowl of the sky in little degree marks, there would only be 31 degrees between the moon and this object, sadly. It's a very bright moon, and perhaps you can see, and once again, this ZWASI 178 monochrome camera, we're looking somewhere, over in here somewhere at an object, and there's the moon. So it's a lot of competition for what we're looking at tonight. But let's come to the live view through the ZWASI 2600 MC Pro, and that's the view we're getting thanks to live stacking. Now, we've been live stacking during the setup about 8 minutes. You can see down here at the bottom, perhaps, if you can read the fine print, about 8 minutes. So we're already seeing this little hazy patch there in the middle. And if we look at the Deep Sky Image Annotation tool, you can see that it's got NGC 6925. It's not quite on target. Let's do this. If we go plate solve only, then it kind of reorients and lets SharpCap know where we're pointing. And that way it synchronizes it perfectly. So let's zoom in on that now. And this is NGC 6925. Let's get the Deep Sky Image Annotation out of the way. It's just a hazy patch, isn't it? Let's see if we can improve that just a little bit. I'm going to hold down the Shift key and bring the night sky just a little bit over, and then let's bring the mids up a little. See if we can get just a little more pop out of that. We're actually a little bit out of focus, aren't we? We can go improve that focus a little bit. Why don't we do that for just for a second? Let's disconnect the camera and then start up Nina. And Nina is the Nighttime Imaging and Astronomy. That's what Nina is an acronym for. Nighttime Imaging and Astronomy software that has a bunch of utilities, and we actually use it for focusing because it is relatively fast and painless. Let's start that. And while that's starting up, let's see if we can find the live Here it is, and check that audio. Okay, I can hear that audio. And then let's catch up with you guys over here. Wendy, it's great that you are willing to say yay about astronomy tonight. Nesrain, good to have you back. You said, yes, my night just got better. And about 10 of us so far tonight like Hyperstar, right? Nesrain says, I love the setup, love the gear. Very kind of you. Okay, so we're caught up. If you don't mind, sometime when you get a chance, just let us know where you're observing from if you're with us tonight. Good to have you here. Nesrine, I think you're from up in Ontario, Canada, if I remember right. So welcome. We're using a different mic tonight. I've been using a mic from DJI just because it's wireless. Yeah, Toronto, exactly. But tonight we switched to a Sennheiser wired mic. I'm hoping it'll be a little easier. Chuck, good to have you aboard from Tulsa. That's awesome. So what's happening? Well, we're using Nina and a particular plug-in there that does the auto-focusing for us. And you can read about that plug-in. I've got it down in the description below. Nesrine, thanks for the mic report. You can look at it in the what some people call the show notes down there. We talk about this particular plug-in in Nina. It's fast. What it does is it takes a picture at a particular place where the mirror is located, and then it moves the mirror maybe 50 stops in one direction. Takes another, actually it's taking 2 pictures in each spot. And then it measures the width of the stars in that spot. And then it goes 50 more. And then it goes 50 more. And it goes 50 more until the stars are so wide that the software can figure out that the disks got bigger. And you know, if the star disks are getting bigger, that means it's getting less focused. So then it goes back to the original spot and it goes 50 stops in the other direction. By stop, we mean the number of notches that our autofocuser, our motorized focuser can run. It's got thousands of notches, stops. So then it goes 50 stops in the opposite direction. And for each particular place, it remembers how wide the star disks were in that space. And then after it can tell that the star disk got a lot wider, it stops and scratches its head and says, now out of all the stops where I have imaged the star points, which ones were the crisp, tiniest star points? And then it uses an algorithm even to figure out maybe it needs to go between 2 stops. And that's what's happening right now. This little green dot is winning out in the algorithm. It's saying, out of all the places I've imaged, the stars were crisper, they were narrower and more of a fine point. In other words, less luminance. They were smaller disks in that spot. So when it gets all the way to the other end and it sees that it can't get any better, it moves the focuser back to that green dot and leaves it there. And that automatically focuses for us. The reason we have to disconnect the camera is because of the way this software works. The camera can only be connected to one software at a time. So we connect it back to SharpCap now. And unfortunately, we lost our live stacking, so we have to clear the stack and image the very first image over again. The object we're looking at is NGC 6925. It is a galaxy, and it's in, as you can see right here, it's in this constellation microscope. Now I just noticed, remember we changed these constellation names last night to the old-fashioned names. It's just a little more how do we do this? Why didn't I save it? Constellation labels. I think we had to change the, we had to change to modern, this one I think. Now, once we do that, microscopium. That's just the nice old-fashioned constellation name. But now I need to save this, don't I? Here we go. Save. View, I guess. Look, it says immediate save. So that it should have kept that. Why didn't it keep that? Well, I guess we'll worry about this later, but it is kind of bothersome that we had to reset that again tonight, isn't it? This is a new version of Stellarium, and maybe there's a separate save here somewhere? No? Well, let's just remember that we might have to come back here and set that again. Anyway, microscopium is the constellation. Let's come back here to the live view again. Oh, I know what's wrong. Here under display histogram, this thing is on again. What I'm doing is tuning up these histogram bars a little bit. So we have the best view possible. This is just a splotch of a galaxy, isn't it? We're at about 92% zoom. But again, this is just 3 minutes. Let's go look at the object. It's 637. 637. This lens-shaped spiral orients north-south and appears nearly 3 times as long as it is wide. The central region is broad and bright. Through a 12-inch scope at 300, you'll spot some of the slightly darker areas that hint at tightly wound spiral arms. You'll find this object, and it tells you where to find it. So not a lot about this. You know, sometimes I have to laugh because why is it that you would want to see this object before you died? I guess it's just so unique, isn't it? Look at this hint of some of the dark lanes here. All right, let's do an observation of this object with this EAA control panel software that Pete programmed for us, custom. Thank you, Pete. This galaxy has a bright core, but overall isn't incredibly detailed for us tonight. Of course, it's just 17 degrees above the horizon, so that's hurting us. But overall, it's a very tiny 4 arc minute wide by 1 arc minute tall galactic disk. It's not that I'm unappreciative. It's just that for us tonight, that's not a great view, is it? I just want to be real, you know. I mean, I'm not going to try to sugarcoat it. That's just, at 5 minutes and 48 seconds, this is not a brilliant picture, is it? The more we move the black level, which is like the base level of your shot, to the left, the more sky glow you get. But if you take it too far to the right, you're eliminating the sky glow, but you're also eliminating some of the galaxy glow. Then you can take the mids a little bit to the left, and that kind of amps up the object sometimes. Not a lot in this case. I love it that Robin Glover, who programs SharpCap, has added the percentage. I don't think that was there before. The percentage to the black level. Now that's a little bit more realistic of a look, isn't it? Even though you know what's hurting us? The moon glow. That's what it is. What it is that the moon is bright enough that it's illuminating the whole night sky, so our software can't milk a lot out of this galaxy. So I'm afraid at just 30 degrees away from the moon's disk at 77% illuminated, that's the best we're going to get this tonight. Okay, so let's, I don't think it's worth taking a picture of that tonight. I will, just because it's there. Just save a snapshot of that. Like when you're on a tour of something, you know, Big Ben is there, you take a picture of Big Ben. Okay, so now let's go back to the 3-second view, and let's look for a next object. What do you think looks good? I'm looking for objects that are higher in the sky, away from the moon, that might be interesting. This would be interesting if we could see it, but boy, it's going to be hard to bring out. It's just 14th magnitude. In fact, 14.8 magnitude. Let's save that for next, because that's going to be hard to bring in with the moon. But I'm not afraid to try it if you aren't. Let's see. Here in this column is our altitude. I don't know how small that print is on your screen. We probably want to be at least 20, if not 30 degrees up in the night sky, ideally. So here is a triple star in Boötes. Let's go look at that, just to kind of get a picture of a triple star system. In the meantime, I'll catch up over here. Windy Louisville, welcome. Tacoma Astro, Tacoma, Washington. Good to have you aboard from the Great Pacific Northwest. Nesrain says it sounds fine. Chuck's looking forward to the Thursday lunar eclipse. Nesrain says yes. Sennheiser is high end. It is, and I'm glad this is working. Chuck, thanks for the mic report. Nesrain uses Sennheiser mics as well. My goodness, the Five Cats Observatory is observing with us from Scotland, of all things. Good to have you aboard from Scotland. Isn't it a little bit late in the evening for you in Scotland? I would say if it's 10, actually closer to 11 here, then in Scotland it would be, let's say, 4 a.m. What are you doing up at 4 a.m.? You must be observing the Five Cats Observatory. Nesrain's always wanted to go. Five Cats Observatory says, it's a special place. Lucky to live in such a beautiful place. I wish I could imitate a Scottish accent. Five Cats says it's a shame it rains most of the time. That is a shame. Dunedin, Florida. Dunedin. The Dwiggy. Good to have you aboard, Dwiggy. Never afraid of the stars, Emerald. 4 a.m. Five Cats says. Are you like? Is your telescope live, and so you're observing there? So you've got this on in the background? My goodness gracious. Okay. Let's do a plate solve. Make sure we're at the right target. We weren't. So here's our target in the middle there. Let's zoom in. Oh boy. So what we're going to assume, I'm assuming that this is our target. It's Pi Botes. I'm assuming that's Pi Botes. And I'm assuming this is one of the three stars, but I doubt that's the third one. I bet they're going to tell us that this is a double star. See how it's a little bit oddly shaped? It looks like it has a little tumor here. See how it's a little oblong? So I'll tell you what, let's do. Let's drop this down to 1 second. Well, these are 1 second snapshots. We're not live stacking here. Let's go to 500 milliseconds and see if we can split that. 300 milliseconds. Rats. We can't. Now I think each one of these pixels, I've got this down in the show notes. I have to go look at this to remind myself. Corin Lewis, good to have you aboard. 1 arc second per pixel is basically what we have. Now, how do I get back to comments now? Comments, live chat. There we are. 1 arc second per pixel. So you can see the pixels here. My guess is that this is actually 2 stars. Let's look the object up and see. It's object 365 in this book, 1001 Celestial Wonders to See Before You Die. And in this book, Michael Bakich, or Bakich, I'll have to write this guy and see, how do we pronounce your name, Michael? Is it Bakich? Do you say Bakich or do you say Bakich? 365. I think it's a Croatian name. So I think it's supposed to be Bakich, but when he immigrated to wherever he lives, he might have chosen to just let it be Bakich. You'll find this nice binary, 6.5 east-southeast of brilliant Arcturus. The primary is white and the secondary is yellow. Oh my goodness. So this is all there is to it. Let's go back up to 3 seconds. Because it's just a binary. No wonder we couldn't split it. So this has a 5 arc-second separation. Is that right? Is that 5 arc-seconds? Yes, I think this is arc-seconds. That's bound to be arc-minutes, isn't it? How can we get... I wish I could see the little... I'm afraid if we right-click on that, it's going to... I think off camera. Can I go off camera? I can't. I'm going to put it on the scope for a second. No, that won't work either. I'm going to have to put it on me for a second. I'm going to say in Astroplanner. Oh, I can just see it now. The object separation, this is for double star objects. The value is expressed in arc seconds. My goodness, it is arc seconds. So it's just 5 arc seconds apart? Let's look at this in Stellarium. So we click on Pete's button here, Stellarium Sync. You can see we're looking at almost due west. And if we zoom in here, pi Boötes, so this calls for look. So that star that we're observing out to the side is not the double. This object that we're looking at that's bright, pi Boötes itself, it is the double star, rats. So that's not the double of this. This is the double itself. Bummer. Which means we're not separating it very well, are we? Huh. So here we're hitting against the limitations of the RASA. We're at 2000% digital zoom. Every one of these little boxes is 1 arc second. And if we use our imagination at these dancing mosaic pixels, we can sometimes see that there's a brightness here, isn't there? And a brightness here. Look at that. We are definitely at the limits of the RASA's ability because we have such a wide field view. We don't have a star splitting scope here. I think we might have been able to guess that this is a binary, but we would have just been guessing. What do you guys think? Oh, some of you are seeing it as Nesrain says he can feel it as an emotional experience. That's awesome. Yep, Nesrain says he can see it. He can see the double star. Every once in a while, the atmosphere just dances in such a way that you have separation. But let's make a mental note. We zoomed in at 779% of our camera's actual capabilities, optical capabilities. In other words, this is way into the digital zoom. With the time set at 30 milliseconds, and our gain was at 400, we could see the dancing pixels separate ever so slightly every once in a while. So we might have guessed that this was a double. But super tough with a RASA. I mean, some people, I don't think they'd even try to split this star with a RASA. But I like for us to try it just so we can see what the edge is of our capabilities with this instrument. And we are looking at it. I would say 10 arc seconds is a better distance for us to remember in our heads. But let's remember this night just so that we will not forget pi botes. The real double star, not from last night. Nazrain says, it's still amazing. Michael, good to have you back. Yeah, exactly. We did a little better with that double star last night, didn't we? All right, so let's search on here is a galaxy at 78 degrees up. And it's 78 degrees from the moon, sorry. 23 degrees high. Still kind of low, but it is 78 degrees away from the moon. Let's try that galaxy just to get away from the moon. Was that it? Is that all the farther we had to slew? That wasn't very far, was it? It wasn't very much movement. Yeah, apparently that's it. This, yeah, it's in Boetes. This is NGC 5523. Huh. What we're doing here is we have a little script written. that automates some of the actions that we had to do over and over again. You can see the actions that are completing up here in this little, it's like a little program, a little simple program, and it just automates some of the house cleaning that we had to do. Boy, this is dim, isn't it? What's the magnitude of this? 12th. Super dim. Faint. Super faint. Yikes. Also, see, because we have to establish such a high baseline, since the moon is at 77%, the light of the moon makes this background light that matches the background light of the galaxy. So when we try to eliminate the background light of the moon and the sky glow of the city of Louisville, actually, that part of the sky is not terrible. Oh, yes, it is. That is the part of the sky that's terrible. Let's go over and look at the, so that's the city of Louisville that you're seeing there. And then this is the moon. And among all the city of Louisville lights and the moonlight, we're trying to look at a galaxy that's probably, let's see, what is it? How high in the night sky is it? 22 degrees. So it's probably right about here. So because we have to dial back all these city lights, we're having to dial back some of the light of the galaxy. Now, lest you think that this is some kind of a daytime shot, it's like a snapshot that I'm dropping in here. This is actual real time. This is like right now. That's how bright the outside looks with the city of Louisville and the moon there. It's a wonder that we can see anything. There's no artwork for this galaxy. So that tells us how obscure it is. Stellarium doesn't even have a piece of artwork for it. It represents it by a little red disc, and that's it. All we're seeing is this faint wisp here. And then there's a little bit of a brightness here. I assume that's the core. Yeah, that's 5523, all right. See how our deep sky image annotation can confirm. This is a feature that's built into SharpCap to confirm that you're looking in the right place. So we are looking in the right place. That is the object. It is just super dim. Let's try bumping the sky glow a little bit brighter. Look at all the tingly glow of the night sky there from Louisville. We have a light pollution filter in. It's down in the show notes. It's basically the Celestron light pollution filter that's designed for the RASA 11. It's like they custom designed it specifically for this telescope. And it's supposed to do the best it can at filtering out light pollution. However, it doesn't do quite as much for galaxies, I'm afraid, as it would for nebulae. It almost looks like confetti, doesn't it? Let's read about this object in Bakich's book 356. Tells you where to find it. Disc-shaped object looks best through 12-inch and larger, although even through scopes twice as large, you won't see much detail. Well, at least we know, even if we had a 24-inch scope, we wouldn't see much detail. What you may notice is a slightly brighter oval-shaped central region. We saw that, surrounded by a tiny bit of haze. That's it. And he wanted us to see this before we die. Oh my goodness, look, it's Tauranga, New Zealand. Don, good to have you back. Oh my goodness, Corin, yes, from Barbados. Good to have you back, Corin. I remember, now that you mentioned, I remember that you're from Barbados. Tauranga. I've always thought that city is just such a cool sounding name. It just makes us want to do the haka. Tauranga. Haka yaka wapaya. Hiya Tauranga. It just makes you want to say it, doesn't it? Anyway, Galaxy is in night mode, can't see me. Michael, you're right. It's a faint smudge of galactic greatness. Nesrain, I like the way you think. Ryder was like, see the smudge? No. That's exactly what he said. Okay, let's do the observation here. Michael summed up. I'm going to say Michael, that is Michael Onaden, summed up Michael Bakich's observation notes. Quote, Ryder was like, see this smudge? Dope. That's so funny. I wish I had said that. Honestly, all we could see was a faint wisp. But at least it had some width and a brighter core. Does it say the magnitude? 12.1. We should be glad that we're seeing anything. Magnitude 12.1. I mean, the limit for our human eyes is like 5 or maybe 6 on a dark sky. So every magnitude that you go greater than that is, what do you call that? A logarithmic scale. So it gets like, not just an increment better, but an increment darker, but multiple times darker with each magnitude. The fact that we can see something 12th magnitude at all is just, to me, amazing, especially on a night when the moon is at 77%. But it does not bode well for this object that we wanted to come and see. Remember, we were going to go see the one that was really dark. Anyway. Where do you want to go next? I'm looking at our distances, our altitudes here rather, and they're all right around 20 something. Let's see if we can get to something up around, here's a 38. Kappa Hercules. It says it's a triple star. The last triple star we went to was just double. Let's go there. I tell you, there's no sense in saving this picture, but we're going to save it anyway just because we can. But This picture is not going to be something to send to your mom, I'm telling you. Here we go to Kappa Hercules. Michael says, yep, that's obscure. Corwin asks, what time it is in New Zealand? Corwin, I think if we're lucky, our friend from Tauranga is going to tell us that it's about maybe 10 a.m. or 11 a.m., something like that. Where was that name? It was a different name than I remembered. Must have changed. Don Luckenstein. Don Luckenstein. I don't know, Don, if you've been on before. Triple star configuration. I wonder how they move. Oftentimes they're orbiting the mass of their star gravity together in the middle in a space. Oh, nest range says 3:22 p.m. Wow, that's crazy, isn't it? In other words, they're orbiting the place of their gravitational mass, which is an imaginary point between them, oftentimes. But if one of the stars is bigger, then that place of that gravitational mass will hug more closely. Well, look, we can see the double. So at least we're going to divide this triple into a double. Look at that. It looks like one of the episodes of Star Trek, doesn't it? And maybe the captain is on another planet and he looks up and there's a double sun up there. You know, I wonder if this is the other member that's a double. Here we go again, right? 30 milliseconds. Let's just jump right to 30 milliseconds and save all that time. I don't know. Maybe that's a double. And then this is the third member. What do you think? Maybe? Yeah. See how when it dances, sometimes it looks like it's separating. How about that? I think this one we're able to split, gang. Hallelujah. That is so funny. About every 7 or 8 seconds, for one fleeting moment, we can see the third member out here. Let's go look at this Kappa Hercules, object 414. Nesrain says, I know all the episodes of Star Trek. I'm not surprised. Nesrain. 414. You'll find Kappa Hercules, and it tells you where to find it. The primary of this close binary appears yellow or yellow-white. The secondary is orange. That's all he says. Let's go to Stellarium. And Pete, thanks for Stellarium Sync. Bam! And let's look at Kappa. Now I wish, now when I grab onto them and move it, it loses its sync. Oh, look. Sure enough. Look at that. Stand still. Okay, there we go. Oh, that's a Gaia star. So that was a false double. We saw this star, didn't we? I mean, you heard us talk about it with your own ears, but it wasn't a binary with Marsic. Kappa Hercules, it's, you know, I think it's just visual double. Distance is 92 light years. This distance is 4 light years. Yeah. And this one is 2.65 light years. So see how it says 7 Hercules B? And this is 7 Hercules A. But this one is Gaia, brrr, all those numbers. It's a visual double, but not a double of Hercules, 7 Hercules. I wonder if 7 Hercules is a double on its own. Let's go look at that. I'm going to call up, shield your eyes for a second because this will be really bright when I first bring it up. And let's go, is 7 Hercules a triple star system? Kappa Hercules. No, it's an optical double star rather than a triple. An optical double. It's not a real double. They're 27 arc seconds apart, but it's not really a star system. What do you make of that? This is only an optical double. It's fake. They don't rotate around each other. We've been tricked. A star behind a star. It's really hard to tell without zoom. I don't know. I'm sure somebody has scanned this for. That's that Gaia star that's unrelated. Well, at least we split it, right? Let's go back for a second to Stellarium. And let's use our little angular deal to calculate this angle. Oh, it says it's 14 arc seconds. That's why we split it. No, it's more like 26 arc seconds. Yeah. See, it says here in our observatory, 28 arc seconds between the two. Well, how about that? In our observation, let's say we were duped. We assumed Bakich had taken us to a double or triple star system, when in reality it's just an optical double. You see the difference. In a binary star system, the stars actually are rotating around each other. But this is not. It just, the stars appear, they appear close to us, even though they're separated by a lot of light years. They appear from our vantage point to be optically a double. Well, still, that was interesting, wasn't it? Misrepresenting it due to poor initial observation. Yeah, that's right. Okay, what else we got here? What else? Oh, you want to see a globular? Let's go to a globular cluster. NGC 6366. NGC 6366. This is a globular cluster. Going to plate solve just to make sure. Is that it? Yeah. It just might. No, I don't think it is. We're not seeing the globular yet. Must be right there. Huh. Let's do this. My goodness, it's supposed to be right there. Isn't it amazing how we can't see any of that yet? So this is what we might see if we were looking through a regular telescope, but it's only through EAA that we start live stacking, and through EAA, what was it, 6366, right? 6366. 6366. All of these software, you can look down in the description, the show notes. You can see each of the pieces of software we're using if you want to learn more about them and look them up. And maybe, who knows, you know, set up something yourself to use. To me, this is just the sweet spot of electronically assisted astronomy, EAA, using SharpCap with AstroPlanner coupled with Stellarium. That triple, speaking of triple systems, that triple suite is just the bomb. With SharpCap, of course, it's just custom designed for EAA. It really is. Robin Glover has done an amazing job basically inventing, through SharpCap, helping us invent a new way to observe. Just really, as of only about 5 years ago, this was possible. And the reason is because we can stack one time exposure. We're shooting 20-second time exposures here at 100 gain. One 20-second exposure on top of another. And it saves all those time exposures in its memory without writing them to your disk. And while it's doing it, it averages the light sources to be brighter, and the light sources that end up like confetti, they kind of glisten, it concludes those must have been atmospheric city lights or maybe moonlight or something glistening in the night sky, and it averages those down. So over time, your image gets better and better in real time while you watch it, without having to do an astrophoto that you might process later. So it really is an amazing creation. Look at that. See, we would not have seen this were it not for the magic of EAA, unless we would have set up some kind of astrophotography setup. But thanks to EAA, this hornet's nest of a globular cluster is visible to us. I will never stop being amazed at what it accomplishes. We're only 3 minutes into this observation. We saw nothing in this frame. And if we had had an 11-inch telescope looking up into the night sky, real time, with our eyepiece, you saw what we would have seen. Blackness. But by just live stacking several 20-second exposures, we're able to see what the human eye can't see. And this looks like a hornet's nest, just bzzz. You know, a globular cluster, unlike an open cluster like we saw last night, a globular cluster is a lot tighter. The stars are actually gravitationally bound, and they usually occur inside a galaxy, or maybe revolving around the center of the galaxy outside the galactic plane, but they still are gravitationally bound to the galaxy. So these stars are all part of the same system. You could almost say this is like a mini galaxy of stars. And they're just hornets nesting around the center of that galaxy, usually not in the disk. They're usually popping in and out of the galactic plane, but hovering close to the center of it. It's a remarkable beast, isn't it? A globular cluster. And if you study this closely, now we're starting to see some of the colors. You guys who have good color perception, Nesrain's getting it. I love EA because the camera sees things the eye doesn't, but as for live viewing on screen, I'm not going to spend time stacking or processing. I'm a visual viewer. Exactly, the eye won't see that. It's a huge system. You bet, Michael. I bet we could get a sense of how wide this is. Let's see if by chance in Stellarium there is any kind of measurement of the size of this. 6 arc minutes is all it says. Shield your eyes for a minute from the brightness, because I'm going to go back out to that screen that's really bright. Sorry about that, but I'm going to look, and as soon as I can find where to go, here we go, that one. How wide would NGC 6366 be in light years? About 50 to 52 light years wide. 15 to 20 light years across its core. 50 to 52 light years wide to its outer extent. It is a loose, sparse, open-looking globular cluster, Shapley Sawyer concentration class 11, that has likely lost many outer stars over time due to gravitational interaction with the Milky Way. "52 light years across." Just beautiful, isn't it? Wow. I wonder if we take that 1 inch farther that way. Make it just a little bit, one notch brighter that way. Just depends on, this is just a personal taste thing, isn't it? I mean, you're just basically observing, so you can set these bars however you like. I see different color differentiations there, but I'm not very good at colors. But are some of these yellow and some of them white? And I'm suspecting that some of these have more of a greenish tinge, I'm guessing. Some yellow, some gold. Ness Rain says, I like it that you give that warning for brightness. Okay, so Michael says he sees orange, red, white, blue. And Michael saw orange, red, white, blue, about 52 light years span across. Boy. Globular clusters. You know, I remember reading that I think there are only about maybe 150 or 200 globular clusters that we can see in the night sky. Whereas open clusters are much more, what would you call that, like prolific or whatever. Shield your eyes again. I'm going to go back out to Google. And I'm going to ask, how many globular clusters have we discovered compared to how many open clusters? 150 to 200 globular clusters and more than 1,100 open clusters. So see, a lot more open clusters. These are globular clusters are tight spherical groups containing tens of thousands to millions of ancient stars, and they mostly orbit in the outer halo of the galaxy, whereas 1,100 open clusters, and scientists believe the real total can be up to 10 times higher, but dust blocks our view. These are loose, younger groups containing a few dozen to a few thousand stars. Fascinating. Fascinating that we could see this tonight together as a group and observe it as a team, real time, when in reality, when we started, remember, all we saw was this. Blackness. It's remarkable. I don't know if we found planets in the globular clusters or not. I don't think so. I think we're mainly, I just don't think so. I think those are ancient stars and they've maybe been stripped away of planets because they're moving through the galactic plane over and over. All right, what do you want to look at next? What does that mean? Constellation. Delta Boötes. Let's just quickly look and see what are we looking at with 383. Oh, it's a wide binary. Okay, another binary star. Here's an open cluster. Oh, it's too close to the moon. We ought to be able to see that. It's 13 degrees away from the moon. Let's go look at it. Come on, let's do it. Let's try it. So this is NGC 6605. It's right beside the moon. Look how bright the observatory looks. You know, some nights just so dark out there, but tonight you can see everything that's going on out there, can't you? You can see all those parts because of the moonlight. The moon is just making it look like daylight out there, isn't it? It's hilarious. All right, so we're going to plate solve here. So what is the open cluster? 6605. Oh, it's down here. So our targeting is a little bit off. Huh. Normally, our targeting takes us so that the object's in the middle, but look how this one's a little bit off. So I'm glad we had deep sky image annotation to tell us where to look. So this is the open cluster that we're here to see. Because there are a number of stars in the background, Alt-D. Because there are a number of stars in the background, the cluster almost doesn't even look like that much different, does it? It is superimposed, in other words. The cluster is flying past a lot of stars in the background. So think about it. If we were looking at this in a night sky, we might not even have considered that a cluster because all these other background stars. .535. This object may or may not be a cluster. There's some debate among astronomers. To me, that makes it interesting, so have a look. If you used a 4-inch telescope, you only see a few of the stars. Through a 12-inch scope, you'll count 75, but are they a cluster? You decide. I see. Okay, so shield your eyes for just a second. I'm going to go out to 6605. Is NGC 6605 really an open cluster traveling together? Very check 1, 2, 3. Yeah, I'm back. I stepped on my mic cable and pulled it out of the laptop. So that's my first lesson at that. That I've been working with a wireless mic all this time, and you can't step on your mic cable. Modern data from stellar mapping missions like Gaia indicates that while a few brighter stars in the region share similar properties, the majority of the stars are unrelated field stars along the line of sight. Verdict. It is considered a very loose, sparse cluster at best, often functioning more as an optical grouping or a very sparse asterism like overdensity rather than a robust, gravitationally bound family of stars born together and traveling as a true cluster. So now we have the final answer. By the way, can I ask, does Chrome have this ability to go into dark mode? Is there such a thing as dark mode in Chrome? Dark mode. Mode. Dark. Oh, how about that? And it is per tab. So how would we do this? How do I make Chrome dark mode? Click the three dots, go to settings, select appearance, change the mode. Well, that's what we just did. But it went back to bright when we close the settings window. This is important, so we don't blind you guys. Oh, look, this is still dark mode. So let's just, if you can't beat them, join them. Yeah, that's a lot more pleasant to the eye, isn't it? Okay. Well, that's a fun thing to learn. Now, how do I edit that observation? Do I have to go here? See, I don't see the observation here. Ah, wonder if it's down here. No. I want to edit that observation. That's all I want to do. Show observation database. 66. Did we not do an observation here yet? That's why I can't edit it. Not really a true open cluster in the largest sense. A few core stars, but most are visually clustered together. Okay. Morwick. What was the first computer you ever had? And would it blow your mind that I asked 15 tech streams what a BBS was and no one knew? Morwick is asking the first computer we ever had and is pointing out that the old days of the BBS, the bulletin board systems, were a thing of the past. You're right. I didn't really like the first little computer I had, and I traded it back in. I think it was maybe it was one of the overgrown calculators, like a Not a Texas Instruments, but you get the idea. That was back in 1983. But in late 83, early 84, I got a K-Pro. Now that was a computer. A K-Pro 2 with the 2 floppy disk drives. That's where I started. How about you, Mark? All right, what do we want to see next? Let's see. Yours is an IBM Clone XT. Yes, I remember those. Pre-286. Yep. So you were circa 1983 or 84 as well. Maybe 85. Let's see. We've seen a globular. We've seen a galaxy. Yes, sir. How about some kind of nebula? I don't think we'd be able to see this. What is a scutum star cloud? Let's go there. Whoops, I forgot to return the, there we go. Warwick misses the old days of tech. You know, I do as well somewhat, but man, I love my HP laptop now compared to that K-Pro. That thing was a beast. 30 pounds. It was like hauling around a giant shop vac just to go to the office and back. You just, honestly, you didn't mess with it. You didn't move it. It was so heavy. Michael says, like the Magellanic Cloud. Wonder what the star cloud is. The Scutum star cloud. We're 19 degrees from the moon. Oh, I bet it's this. You think? I tell you what, let's do. Because I don't think this is going to be in the deep sky image annotation. It's not. So what we have to do is we have to grab these coordinates using the SharpCap DSA button that Pete has given us on our EAA CP panel here. When we click this button, whoop, put you back on the screen. When we click this button, SharpCap DSA button up here, it copies the coordinates. And then we come over here, Alt-D, puts the, and then we say paste custom object info, and it shows us where that object should be. So it should be right here. So let's close that now, and let's live stack this and see if we can see what this is. Scutum star cloud. Sounds mysterious, doesn't it? Oh my goodness, it says it's 4 degrees wide. This calls for Stellarium. Now we're going to do Stellarium sync and say, what is the Scutum? Let's put our field of view on this. Do you think that is the Scutum star cloud? Yeah, this is a custom marker that I added, or that someone added. Maybe I didn't. It says the type is a star cloud. Can you see the background? Kind of like, it's almost like background radiation here. Do you think this is it? And that? Yeah, I think these are it. And Nazarene out of Texas Instruments as well. So I think what we're looking for here is like this glow. And since we're just 19 degrees away from the moon, I have no idea if we're going to be able to see this or not. It doesn't show a magnitude, and this doesn't provide a magnitude either. I guess because it's so diffuse. Let's go back to our real-time view. And let's let this cook for a while. See this pattern here? I would call this mottling. Isn't that the word? Now I don't have to tell you to beware. Oh, I do, because definition of mottling. How do you spell mottling? Mottling. M-O-T-T-L-I-N-G. An irregular arrangement of spots or patches of color on a surface or object. Look how that turned white when it came back to the definition. But that was black before. So it's not a perfect world, Google. See how this is kind of mottled here? It's an irregular, patchy look. And in my experience with our RASA and with this rig that we've got, that's what you start seeing when you're going to see this kind of a cloud thing. It's like, see that mottling going on? That's what this rig does. I don't know if all EAA rigs are like that, but it starts showing you a patchy look. Not Apache, the Native American, but Apache, it's patchy. See how that has like parts that are darker and lighter? Some of that, this glow over here, is due to an ever so slight alignment issue in my camera. And I just gave up one night when I was trying to align the camera and said, okay, I'm going to live with that. But this cloudy look here is not. This is embedded in what's behind all these stars. Can you kind of see that? Starting to make that out ever so slightly. Nesrine says, most patchy indeed, very faint. You're right. Let's go ahead and say this. we could make out the patchiest, the faintest hint of a patchy cloud behind these stars. Now let's call this up in the book, Bakich's book. It's object 556. You have to have a dark, clear sky. And it says, Michael says, you'll notice this region looks like it contains more stars than nearby areas. We call such spots star clouds, and indeed, lots of star information is happening here. Would be fun to look at this patch through binoculars. In a dark sky sight. Unfortunately, we have to travel an hour and a half or so to get to a dark sky sight. But look, you're starting to pick this up even more. Look how there are lots and lots of faint stars now we're seeing. It is amazing, isn't it? That's 150 degrees above optical zoom. Look how they just keep on going. Star after star after star after star. And there are little asterisms of things. See if you can see any little asterisms. Here's a little 5 on a die, or a old-fashioned jacks you used to play with in the street. This is a marimba and its legs. This is a man, and he's got his arm up, and there's his head, and this is his other arm, and he's about ready to throw a baseball. There's his arm, and that's his upper body, torso. This is a ray gun. That's the top part, and that's the part you hold on to. It's from an old Buck Rogers black and white rerun. So many stars. Paw print patches. Shadowous veils. Ooh, that's a neat way to put it. Shadowous veils. Nice. All right, so we've seen globular, open, galaxy, double, fake double. Well, let's try to look at a dark nebula. I don't know if we'll be able to see it. Let's try it. This is a lot of fun with you guys. I used to do astronomy out in the field with an old-fashioned 8-inch telescope. Lonely. I would hear things go bump in the night, and I would think, okay, that's somebody coming to get me right now. My life is over. And I was by myself, and it was damp. Oh, my, clammy. My clothes would just get completely cool and clammy. And man, it would be so lonely. I'm serious. It would just be lonely. And you know, you couldn't see that much because with an 8-inch, this was an old Schmidt Cassegrain 8-inch Celestron is what it was. I'm digging around down here for some M&Ms, guys. I wish I could share some M&Ms with you. These are dark chocolate M&Ms. I feel terrible eating in front of you. That's terrible. I shouldn't be doing this. Should I? Nesrain says, this is my favorite show podcast. That is really nice. Oh my goodness. Nesrain has an 8-inch Edge HD. You know, your Edge is better than my old Celestron CPC something, 800 or... I couldn't see very much at all with it. I didn't drive out to a dark site very often. I didn't have it set up for photography. I mean, to be honest, Bernard 117. To be honest, okay, the Andromeda Galaxy looked good. And yes, you could see M42, the Great Nebula of Orion. Those two were showstoppers with that 8-inch telescope. Everything else. No, I'm exaggerating. You can see open clusters and stuff. I take that back. This is so much more fun, though. Boy, that is a star field, isn't it? Take a look at that. I feel like I'm in the Enterprise. I mean, think about it. Ba da 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 da. Was that the original Star Trek theme song? Da 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 da. And then it went to ba 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 ba. Was that it? No, that's Star Wars, isn't it? What was the Star Trek Next Generation theme song? I got these mixed up. Oh boy, we're gonna have to go out and play Star Trek Next Generation theme song. We're gonna have to do it. We gotta do it. We gotta do it. You know we gotta do it. YouTube. Now I'm only gonna play 15 seconds of this because if I don't, if I play more than 15 seconds, Star Trek Next Generation theme song. If I play more than 15 seconds, it'll be a violation of copyright. So somebody start the clock. Here we go. Ready? I don't even know if this will play through. How do I make sure this will play? Let me go down here and look. I got to go to settings. And then I got to go to audio and desktop audio default. I think that'll play now. I hope. Okay, 15 seconds. That's all we're going to do. Ready? Go. Okay, that was fake. That's not even the right song, is it? Expanded theme song.
And new civilizations.
Okay, so it was. Ba 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 ba. Okay, so there you go. Jeff from Montana, you changed your YouTube name, Beartooth Astro. Good to see you again, Jeff. Long time, for sure. You guys are talking about the scopes you had. Small scope started watching the moon all summer, and being in Ohio, the moon rose a lot over this area. Good times. Yes, you were right, Nesrain. I had to fast forward over the dialogue. Space, the final frontier. These are the voyages of the Star Trek Enterprise. To go where no man has gone before. Whatever. Okay, so it's correct in the original one as well. Jeff, how are you doing? Now, you've got an HD. You've got an Edge, don't you? An 8-inch Edge telescope. We were just talking about your scope. Okay, in this star field, we're supposed to be looking at a dark nebula. Okay, so see it right there in the middle? Look at that. This is a dark nebula. So what it means is there's a big star field behind it. But in front of the star field, there are these soot clouds. And that's called a dark nebula. It's covering up the stars that we think are behind it, and only some stars are showing through. And it's kind of like a river of dark cloud. Isn't that crazy? Let's sharp cap DSA that from our little control panel and go back here and start deep sky image annotation and paste the custom object in. So there's the marker for Bernard 117. But what we have to remember is it is this entire area here. Let's go to Stellarium. Where did Stellarium go? And let's do Stellarium Sync. And see, this is the part we're zooming in on. I don't think Stellarium does a great job at helping us understand what this dark nebula is. Because there's no like art there to show us, is there? But you kind of have to just look at what you're not seeing. That's basically the way we observe dark nebulae, is we get a sense of the big picture of all these stars. And then we look at what we're not seeing. And we think, okay, so that must be covered up by something. Otherwise, we reason that there would be stars behind it. Interesting, right? we could see rivers of darkness flowing in and out of this rich star field. If it weren't for the richness of the stars, we probably wouldn't even have known that the dark nebulae were there. Let's go look at another one. That's Barnard 117. Let's look at Barnard 118. It might not be very far away. My sense is sometimes these actually are in the same field. We'll go ahead and slew to this one. Oh, look at the clouds moving in up there. That's a bummer. Rats. Look at them. So this is Barnard 118, supposedly. See, even just looking visually, I'm not sure we would be able to have any clue where a dark nebula would be. But stacking the field helps us see. Yeah, Beartooth Astro Jeff says he has a 8 and a 9 1/4 edge HDs. Started the hobby with the 8. Exactly what people say not to do. Yeah. Michael says, storm clouds in space. You're right. Had a friend moved out of town a few years ago and basically gave me the 9 1/4 on the cheap. Michael, you're wondering how the atmosphere is in the dark nebula. I think we need to think of it just as a cloud of soot. And because these distances are so great, it's not the way you see it in Star Trek Enterprise when they're moving in and out of these clouds. These distances are so huge, I don't think we would even be able to perceive that we're in the dark soot. It's just such vast distances. Okay, so again, the dark nebula is the place where the stars aren't. Look at all those stars. It's like dew glistening on the morning of a hayfield, and here is that dark nebula. I wonder what we could do to see a map of these. Let's do this. Let's just look and see how, whoops, that's the wrong computer. That's the computer out of the observatory. We're going to have to use this computer. Yeah. Let's see how SkyTools 4 pictures these dark nebulae, if we can. I tell you, I have a hard time going back into Sky Tools 4, because with deep respect to the developer, you can't just hit Control F and look for something, you know. Like in Astro Planner, if I want to find Bernard, wait, why don't I do this? More rivers of blackness. If I want to find Bernard 116, I go Control F and I literally say Bernard 116 and hit find, and it finds it. And I think that's the way the program should operate. It takes your cursor there. But in Sky Tools, let me get back to the right computer here. In Sky Tools 4, there is no Control F. And I even contacted the developer. I said, look, I know you have this certain way that you think we should be using your program, but with deep respect, I would like to use your program in a different way. I would like to use it for EAA. And sometimes I just want to find where something is. Now I'm going to hit Control F. It just doesn't even exist. So what I have to do is put things in order of primary ID, and I think they are, and then manually try to spin down here. And here's B116. Yeah. So see, it can be done, but you just have to kind of make allowances. Another problem is if something's called by another name, see, like, look how these are NGCs, but if you had it alphabetized by primary ID, you wouldn't be finding them in order of NGC. So it's just a train wreck to find things, especially in a list like this with 1,001 objects. It is a train wreck. So I have trouble going back to it. But what I do like about Sky Tools 4 is, look, I can hit the letter A here, and it brings up a nice atlas. I was just curious, what did Greg do with these in his atlas? And you can see he did not try to draw the dust lanes. He just represents it with a marker and then a box. Bummer. Okay, so let's get rid of that. And let's go back out to Google and say Bernard 116. Because, I mean, is this Bernard 116? Is this it right here? I suppose it is, because we plate solve, so it's going to put it in the middle of our screen. And if we go here and capture the coordinates and then paste them here, here's where it says Bernard 116 is located. Let's go out to Google. So shield your eyes if I don't have this set up correctly. And let's say a map of Bernard 116, 117, 118 dark nebulae, and see what here's a guy in Astrobin that's trying to show them to us. Now this looks good, doesn't it? Oh, and that looks good. Space Wiki fandom. Let's take a look at this. There we are. Have you guys ever been to Space Wiki before? I haven't. Got all these social media people here, but this is what I was looking for, is kind of like, where's a map of what we're looking at here? And right now we're looking at Barnard 116. It's off the map. These are photographic plates. Man, look at that. So it's showing you all the different Barnard 22, 19, 217, 216, 213. These are all dark nebulae here. Isn't that beautiful? That's Barnard 18. So what you're doing is you're taking a picture of what's not a star. Wow. So look at all, let's get rid of this. Look at all these wisps of clouds. Is that it? Yeah, that's it. I wonder if I change this to 16. Yeah. Look, see, that's what we're looking at. That. It's just blackness in the middle of the star cloud. And that's all they have for 16, is that blackness. So right here, just this blackness. Blackness. So dispersed. You could be dropped in the middle of it and you wouldn't know you were there. Exactly. It's like the asteroid belt or the Kuiper belt, right? Right, like the Earth, the moon, distance looks close, but it's really far. Everything is so far apart. Sky Eye and Stellarium, but no, no scope. These stars look like they're next to each other. Yeah. Right. You guys got it. Okay, while we're at it, let's just do one more. Barnard, I bet these are the same. Let's just capture. No, we can't capture it. We have to slew to it to be able to capture it. So let's, because we're capturing it by virtue of the fact that it's been entered into the brain of the Sharp Cap TSA, Deep Sky Image Annotation, paste. So there's 115. The good news is this stays in here. So next time I use Sharp Cap and go to these, they'll still be here. Look at those. Those are Earth clouds coming in. Let's do one more while we're at it here. Slew to object. Oh, that's where we already were. Blackness. Let's pick up this last one. Slew to object. $114. Oh yeah, it's right there in the middle. So these are all in the same field of view. Let's take a look at our sky cam, and that shows you what we're dealing with now. This is quite a cloud base. So we're going to have to call it, and it is 12:36, so we've done our 2 hours. You guys have been a great audience tonight. This has really been fun. Thanks for making this a team sport. Thanks to God for making all these cool objects. We looked at globular cluster, open cluster, double star system, visual doubles. We looked at galaxies, nebulae, and all of this with the moon at 77%. We saw good friends that we hadn't seen for a while. Jeff I haven't talked to in a year or two. And Tauranga, New Zealand came on. We had Scotland, we had Toronto, we had Florida, we had, Montana, we had all over. We were around a dozen people together. Corwin, good to have you back. We're thankful for the fact that you were here. And if you're watching this recorded, welcome as well. Even though you weren't here live, we love it that you were here on the recording. If you like content like this, and only if you want to, if you wouldn't mind subscribing and hitting that thumbs up, the like button or whatever, that gets the content up in the dashboard of somebody else that might not have seen it otherwise. And it doesn't cost you anything. But I want you to know how grateful we are for this community and how fun it is to do astronomy as a team rather than the old way. We'll be back next clear night. We'll be back and we'll keep working our way through these 1001 celestial wonders to see before you die. God bless. Have a great evening, and we'll look forward to seeing you again. Take care from the outskirts of Louisville, Kentucky. This is Doug from Emerald Hill Skies. Good night.